Guys, welcome to YouTube channel Foundation JEE. Today's lecture is continuation of our previous three lectures on sound. In that lectures, we learn about definition of sound, why sound wave is mechanical wave, because for propagation of sound, medium particles are required. Guys, sound wave is also known as pressure or density wave because when the sound propagate in medium, then there is variation of pressure and density of the medium. Guys, we also saw the wave characteristic of sound, in which we saw wavelength, frequency, time period and velocity of sound in medium. Guys, in second lecture we learned about pitch. Pitch is responsible for distinguish between the two sound or voices when they have same amplitude. And we also saw the definition of amplitude and seen how the loudness of sound depends upon amplitude. Guys, in third lecture we saw reflection of sound and also saw how the echo of sound work and saw the reverberation and how the multiple reflection of sound being used in stethoscope, which is being used by doctor to see the health condition or heart or stomach condition of human being. Because when they use the stethoscope, then due to the multi reflection of sound, the sound wave reaches to their ears, and as a doctor daily heard so many heartbeats, so they can easily distinguish between a good heartbeat or abnormal heartbeat. So we all discussed in last three lectures. The link of all these three lectures, which have already been uploaded in YouTube channel Foundation JE, given in the description box. Okay, now today's lecture we will study about hearing of sound, in which we see what is infrasound, audible range of sound, and ultrasound, and we also see sonar. And after understanding of all these things, we will solve one numerical problem. So first we see hearing of sound. Okay, so hearing of sound. Guys, when we are talking about hearing of sound, then The range of frequency 20 Hz to 20 kilohertz is known as audible frequency, which can be recognized by human brain. Okay, now the frequency less than 20 Hz is known as infrasound. Okay, so for example, who can hear this frequency? So rhinoceros can hear frequency of 4 Hz. Okay, now the frequency which is greater than 20 kilohertz is known as ultrasound. Okay, guys, have you ever been heard that earthquake came and animals die? The probability of disaster of animals in earthquake is very low. Or you can also heard in tsunami the animals disasters are very low. Why? Guys, you can remember these things for your knowledge or examination purpose. When earthquake came before main shock wave, low frequency vibration are generated. Okay, so what's happened if there is abnormality in surrounding, then this type of frequency are recognized by animals, or what's happened, they leave the place and go the safer place. Okay, guys, you can also see in your daily life, suppose the day is sunny or quickly the weather change and now it becomes cloudy, then you recognize that rain may be happen 1 hour or 2 hours, then you quickly go to your home or safer place so that you cannot wet by rain water or maybe lightning. So you observe the abnormality. Why? Because you are seeing the surrounding or environment daily. So such type of also observation recognized by animals before coming the main shock waves of earthquake. Okay, so now you understand why when earthquake or tsunami came, then animals does not destroy in such type of natural calamity. Okay, so who can guys heard this 20 kilohertz frequency? So bats, or you can say dolphins, etc. can hurt such type of frequency. Okay, now guys, uses of ultrasound. Okay guys, the frequency of such type of sound is greater than 20 kilohertz, so they travel in a straight path. Okay guys, one thing you remember that ultra sound cannot bend around the corner. Okay, what does mean? We can see when we see the uses of ultra sound. Okay, see first use of ultra sound. Ultra sound uses. Okay, first use, it is being used where it is difficult to make cleanness of object. So such type of object may be a spiral tube, electronic gadgets, watches, etc, etc. Okay, so how the ultrasound being used for cleanness of such type of sophisticated equipments? Okay, so what they do, suppose this one is a container. Okay, so they make a such type of detergent liquid solution. Okay, or they put the object, suppose this one is a object. Okay, so they send the here ultra sound. Okay, so due to the high frequency, it create a bubble, or you can also say cavity. So rapid, they create a bubble or it burst. Okay, so when it burst, then it releases temperature and pressure. Okay, so such temperature and pressure drop out, or you can say detached the dirt and grease from object. Okay, so such way the ultrasound being used for cleanliness of object. Okay, now the second most important uses of ultrasound is for detecting the flaw in metal flaw, or you can say crack defect detection. Okay, so what's happened, suppose this one is a here metallic object. Okay, or here is a flaw, means there is a crack. So what's happened here in this end, right side here end. Okay, they put the detectors. Okay, so ultrasound going like this, or if there is no any flaw, means suppose this one is a metal or there is no change in any medium in the path of the ultrasound, then it go directly from here to this detector. Okay, now suppose the second one also not reflected back because there is no any defect in his way. Okay, now suppose other ultrasound wave are going like this one. Okay, so what you see in this one, the second one, the flow is coming, then when the ultrasound goes here, then it's reflected back, or it does not reaches the detector. Okay, so if it is not coming to detector, then easily the person who is making experiment, he can say in this metal there is defect. Okay, so whenever ultrasound travel in medium or there is change in medium, then it's reflected back. Okay, so one question arises in your mind, guys, could we use other sound for detection of flaw in metal? So answer is no. Why? Because just I told you that when you use the sound wave which is not ultrasound, then they bends to the corner. Okay, so bends around the corner. Okay, so what's happened, suppose there is a flaw. Okay, or this one is a not a ultra sound wave. Okay, so what's happened, if flaw will come, then depending upon the wavelength, okay, they are totally emerge or they are coming like this, making a shape like this. Okay, circle. So which is depends upon wavelength of this ultrasound. Okay, so this phenomena is called bends around the corner. Okay, so what you see, the sound wave is totally emerged out, or it is passing through the floor or coming out with the same intensity to other end. Okay, so we cannot use other sound wave for detection of flaw in metal. Okay, so hope these two uses are clear to you. Okay, so guys, ultrasound is also being used in ultrasonography, in which what they do, they send the ultrasound and it strike on the body part, suppose heart, and then the wave is reflected back, and this electronic signals they converted into images, or you can see it on computer screen, and finally they take the printout, or so they say about the health condition of heart or kidney or any other human organs. Okay, now guys, ultrasound being also used to break the stones in kidney, and when the stones are break up in small particles, then it can be flush out from urine. Okay, so such way ultrasound being used in our daily life. Next we will see sonar. Sonar. Okay, so SO stand for sound. Okay, N is navigation, this one, or this is ranging. Okay, so suppose guys, if you want to know the depth of seabed and where the object is in water, then we also use the sonar, in which we uses the ultrasound. Okay, so see how this work. Okay, suppose this one is a boat. Okay, or this can be used to find out shape of seabed, sunken ship, submarine, etc. Okay, so sonar is being used to detect the position or direction or movement of object under water. Okay, you remember these things. Okay, so suppose here is another object or seabed. Okay, so what's happened here is a transmitter. Okay, so it send the ultrasound, and again after reflection back it goes to here detector. So what you see here, suppose velocity of ultrasound in this water here, area C is V, then time taken by this wave to come back is, if t, then how much distance is travel? 2d. So 2d equal to vt. Okay, so such way guys, sonar system is being used for detecting the shape of the seabed, sunken ship and submarine. Okay, so here sound wave is coming, suppose this way, or again after striking the object it return back and the detector receive the signals. Okay, so they can easily find the distance of the object from here to this position. Okay, now see one numerical question for your better understanding. Okay, on boat ultra sound send on sea bed and return back after striking a submarine in 4 seconds if a speed of ultra sound in sea water is 1500 meter per second, then find distance between boat and submarine. Okay, so guys, here solution, suppose this one is a boat or this one is a here submarine, so here ultrasound is going and again received by the detector. Okay, so what you see here, the total time taken by ultra sound to come back to its initial position equal to 4 seconds. Okay, so total distance equal to speed into time, here speed is 1500 meter per second or this is 4 second. Okay, so this second cancel out, so this is coming 6000 meter. Okay, so this is the total distance sending ultrasonic sound wave which strike here and again return back. So you can say this is equivalent to 2d or this is 6000 meter. So d equal to 3000 meter. So distance between the boat and submarine is 3000 meter. Okay guys, so this is about the sonar system. Guys, you know the sound wave is a longitudinal wave. Okay, in which medium particles are vibrating along the wave motion of sound. Okay, so always you remember this thing, that sound wave is a longitudinal wave. Okay, so see this by one experiment. See, this one is a spring. Okay, now what's happened if you back and forth, see what's happened here. The wave is propagating here along the direction of wave motion of sound. Okay, so that's why we say the sound wave is a longitudinal wave. Okay, so you remember this thing. Okay guys, the other one is a transverse wave, so in which medium particles are vibrating perpendicular to motion of wave. Okay, so guys, you have seen a pond in which waters are deposited. Okay, so when you throw a stone, then waves are created like this one. Okay, so what you see, the particles are coming here, see, like this shape. Okay, so if we draw like line this one, so particles are coming here, here, so this one is a direction here like this one. So what you see, they are coming up and down from this wave motion. Okay, so that's why wave in which medium particles are oscillating perpendicular to motion of the wave, then such type of wave is called transverse wave. Okay, so example, so water waves, light waves, or electromagnetic waves, etc. are example of a transverse wave. See this one by example. See, this is a spring. Now if we will do like this one, so what happened, you can see again, see. So what you see, the particles are vibrating perpendicular to the motion of the wave. Okay, so now we have almost covered all the topics of class 9th physics. Hope you have enjoyed this lecture by listening and watching. So thank you very much. Have a nice day.